Hello everyone, this video is about solving modulus inequalities by squaring. Let's see this first example. First of all, we square both sides. So we get 4x squared plus 4x plus 1 is smaller than 9. Subtract 9 from both sides. 4x squared plus 4x minus 8 is smaller than 0. Divide by 4, x squared plus x minus 2 smaller than 0. Factorize x minus 3. X plus 2, x minus 1. We get the critical points x equals minus 2, x equals 1. Then we draw a number line, minus 2 plus 1, and if we solve a quadratic inequality, we check the sign of each interval by plugging in some random numbers in each interval. If we plug in 0, so we plug in 0 right here or right here. Of course, the easiest is right here. If we plug in 0, from here we get something positive, from here we get something negative. Positive times negative is negative, so that means it's a negative in the middle. And if we try something bigger than 1, such as 10, we plug in 10, we get something positive. Plug in 10, we get something positive. Positive times positive is positive, so in this interval we have a positive, and in this interval we have a positive if you try and plug in some random numbers. So since we are looking for smaller than 0, which is negative, so that means the solution is the one in the middle. So the final answer is therefore x is between minus 2 and 1. Let's try another example. Again, just like solving modulus equations, we square both sides. We have 4x squared minus 1428x plus 49 is greater than or equal to x squared plus 2x plus 1. Move everything to the left. 3x squared minus 30x plus 48 is greater than or equal to 0. Divide by 3. X squared minus 10x plus 16 is greater than or equal to 0. Factorize x minus 8, x minus 2 greater than or equal to 0. So we have x equals 8, x equals 2. The number line, critical points 2 and 8. Check for the sign on the left here. If we plug in 0, we get a negative, so positive. So this must be negative and this must be positive because it's a quadratics. And we're looking for bigger than, so that means the solution would be smaller than 2 or equal to, because we have equal sign here, or bigger than or equal to 8. So from the two examples, we can simply ignore the original modulus inequality and just solve the quadratic inequality. Now let's check out this example. Again, we square both sides, so we get x squared plus 10x plus 25 is greater than 4x squared plus 4x plus 1. And move everything to the right. We have 3x squared minus 6x minus 24. So it's smaller than 0, or we can write it down like this. Divide by 3, x squared minus 2x minus 8, smaller than 0. And we have x minus 4x plus 2, smaller than 0. X equals 4, x equals minus 2. The number line -2, 4, and if we check the interval in the middle, we have, it's right with 0, we have negative, positive, so it's negative, positive, positive, smaller than 0. That means the solution is between -2 and 4. So in conclusion, we have the solution is between -2 and 4. Now let's check the solution here using symbol app. Absolute value x plus 5, so x plus 5 greater than 2x plus 1. Let's see the solution. It says the solution is only x is smaller than 4. So it's different than our solution here. Now, in case you are wondering why, well, that is because we cannot simply ignore the original modulus function. Well, this makes sense because, first of all, if we just ignore the original equation here or inequality here, what difference does it make if the original question actually has also modulus function on the right? We will get exactly the same solution, which doesn't make sense. And second of all, this is something in modulus on the left side, so it's got to be 0 or positive. This is bigger than whatever negative. So if the 2x plus 1 is negative, of course it'll be also the solution. So if 2x plus 1 is smaller than 0, or if 2x is smaller than -1, or if x is smaller than -1/2, actually that's also a solution. So here if we add another critical point, -1/2, anything smaller than -1/2 is also a solution. So actually we have to combine this with another set of solutions. X is smaller than -1/2, and in total we use everything smaller than -1/2, but we also use between -2 and 4, which means in conclusion, so this is actually not a conclusion, the final answer is x is smaller than 4. So as you can see, it is okay to ignore the modulus functions here to just solve the the quadratic inequalities, no problem, just ignore the original. But here we cannot do that. So in conclusion, if you want to use this method, you have to square both sides, check the inequalities, and then you have to check the acceptable ranges, and also you have to check the critical points actually. So this method is not recommended for certain types of problem. That's it. I'll see you again next time.